Not differentiable at a what or a what? Corner cusp. Also, f is not differentiable at a discontinuity. We have a jump, we have removable, and we have infinite. And finally, f is not differentiable at a vertical tangent. Consider the function f of x equals the cube root of x. At x equals 0, determine whether f is defined, continuous, and differentiable. Cube root of x graph, it starts at 0, 0, or I like to start at 0, 0. To the right, you're going to go over 1 up 1. You go all the way over to 8 because the cube root of 8 is 2. To the left, cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. I like to call this graph a snake because it's slithering across the page. Does anyone have a snake or know someone who owns a snake? What do snakes eat? Has anyone seen a snake eat mice or the rat? Yes, it's like a big bulge. So it's like it has to unhinge its like jaw. And then you see the thing moving through its body. It's something. So you guys, guess what this is right here? It's the rat that it just ate. When you graph this, if you have to do a horizontal shift or a vertical shift, you're going to shift to the rat, the math major in college. And then I go to teach this class and I'm writing the notes and I'm like, where is James Stewart going with this? I'm looking at this graph and I'm like, is the graph defined at 0? Yeah. Is it continuous? And no breaks. So yes, the graph is continuous at x equals 0. And then we got to, is the graph differentiable at x equals 0? Again, the first time I read this in the textbook, I was like, I mean, it looks fine. Like, what's the slope of the tangent line? That looks legit. And then I put on the graphing calculator. We're going to graph the cube root of x. So I'm going to go math 4, you got cube root of x. Negative 10 to 10. Whole math career. I was like, yeah, it just looks like a normal curve. Like, wait a minute. I feel like we need to change this viewing window. So I'm going to go negative 0.5 to 0.5. So we're really zooming in here. Blew my mind. I'm like, what? What is happening right there on that cube root of x? We have a vertical tangent at 0. So therefore, is this graph differentiable at 0? Oh, who knew? Well, I'm sure many people knew. Chase, you knew. I didn't know. Now we know. At a vertical tangent, the slope of a vertical line, everyone, the slope of a vertical line is what? Undefined. Perfect. We're going to graph f prime. As you're coasting along this graph and you're thinking about the slope of the tangent lines, they start off positive on the left. Are they getting more steep as you get closer to 0? Once you get to 0, you have a vertical line. So because these are positive slopes, where is this graph going to be, above or below the x-axis? And you shoot up, it goes really fast up. Vertical asymptote at 0. Now, on the other side here, the slopes start off very positive. They're still positive. They're just becoming smaller values, but again, all positive. Since these slopes are all positive, prime should be above or below the x-axis. Above. They start off really high, and then they come down. Still positive, but they get closer and closer.